Hi, good evening all. Is I am audible? I am audible to you guys. Niranjan, Arjun, I am audible. Okay, Arjun. Okay. 1 second. Hi, good evening all. Welcome to Manorama Horizon Free Revision class. Today we will be dealing with the chemistry second chapter, 9th grade. Chemistry second chapter is matter around a sphere. So, we will wait for another 2 minutes to others to join. Okay. If your friends is joining, please call them and tell ki join the class. Okay. We will wait for Let's start the class. In this class, we will be discussing about the what is mixture and its a type. Next, we will discuss about what are solutions and types of solutions. Next, we will discuss what are physical and chemical changes. Then lastly, we will discuss what are the types of pure substances. Okay. Yeah. So when you go to market, you notice the word pure on the pack of many materials such as ghee, salt and milk. So for common man, pure means it is not adulterated or it is not having any impure substances. So, but chemist, for chemist, it's like when chemists see pure milk, then they think it is not pure. It is a mixture of fat, water, protein, etc. So for chemist, milk is a mixture of fat, water, protein, etc. So now we will see what is meant by pure substance. Here, pure substance, the constituent particles of that substance are the same in their chemical nature. Means the constituent particles of the substance should have same chemical nature, then that is considered as pure substance. Pure substance consists of single type of particle. Then, in other form, a substance is a pure single form of matter. Okay, now we will discuss what is meant by mixture. You can see here two round bottom flasks. One flask contains water plus salt, that is salt solution, and another round bottom flask contains water plus sand. So mixture is a mixture contains more than one pure substance. That is, here water is a pure substance, salt is also pure substance. So, and can you repeat the pure substance? Okay. Okay, Niranjan. Here, all the constituent particles of that substance are the same in their chemical nature. Means pure substance, for example, you can take any elements. So gold. So the chemical nature of the particles of gold is same. Understood? So like when you take an example, like when you see that pure substance, you take an example of metals. So metals are pure substances. So pure substances, the constituents of pure substances have same chemical nature. Like they have the same chemical nature. So such pure substances are called, such substances are called pure substances. Niranjana, have you understood? Okay, ma'am. Okay. Next, we will move to the mixture. Okay. So mixture contains two or more than one pure substance. Water. So here I will explain. Water is compound. It is made up of hydrogen and oxygen in the ratio 1:8. So it is a pure substance. Salt is also a pure substance. For example, NaCl is a salt. It is a compound. So it is a pure substance. A mixture contains more than one pure substance. So if a substance, like if anything contains more than one pure substance, then it is called mixture. Here, water plus sand is also a mixture. Next, we will learn types of the mixtures. The mixtures can be classified into two types based on the constituents that take part in the formation of mixture. So there are two types, homogeneous mixture and heterogeneous mixture. So can you see this? 1 minute. Can you see this? Here, sugar and water are added in beaker. When we stir that content in the beaker, sugar solution is formed. So here you can see that there is no sugar crystals are present in this solution. So homogeneous mixture have uniform composition throughout. So you cannot see any particle in homogeneous solution. So here homogeneous solution have uniform composition throughout. Next, homogeneous solution have variable composition. Means instead of here, let us take an example. Here you have added 1 spoon of sugar and water. Then you made a solution that is the sugar solution. So when, like instead of 1 spoon of sugar, if you add 3 or 4 spoon of sugar in same quantity of water, then the thickness of water is increased. Like it get dissolved and thickness increases. That is called, like it becomes just concentrated compared to a previous one. So here the composition is varies in homogeneous mixture. Okay. Next is heterogeneous mixture. So here, for example, see, we have sand in one container and water in one beaker. So when we add sand in water, we get this solution. So Here you can see two distinct parts, like sand is settled at the bottom and water is above the sand. So you can see two distinct parts in this, and the components or the composition is not uniform in the heterogeneous mixture. So heterogeneous mixture consists of two or more parts which have different composition. That is non-uniform composition. So here uniformity is not there. It is non-uniform. Okay. Anybody have doubt in this till now? Anybody have doubt? No one? Okay. Okay, Deepak. Let's move to the next slide. So now list the point of differences between homogeneous and heterogeneous mixtures. Can anyone tell the difference between homogeneous and heterogeneous mixture? Anyone? Okay. So we'll see the answer. Uniform, yes. John, yes. Uniform composition, yes. It is in homogeneous mixture. So homogeneous mixture have uniform composition, but heterogeneous mixture, they do not have uniform composition throughout. Okay. Next. Okay, indistinguishable from each other. Yeah. Homogeneous mixture have uniform composition. Yes, sister. Next, in homogeneous mixture, they do not have physically distinct part. As we seen here, there is no distinct part in homogeneous mixture, but in heterogeneous mixture, there is a distinct part. Okay, then they have same properties throughout the bulk, but in heterogeneous mixture, they don't have same properties throughout the bulk. Okay. Next, we will do an experiment, like we will do small activity. So consider it this as beaker 1, this as beaker 2, this as beaker 3. Bulk means like, see, what to tell? One. So bulk means if you are taking a quantity like, so you are taking some quantity in a beaker, it's like huge amount. Bulk means in huge amount. So you understood? Bulk means huge amount. Okay. So just take 1 spoon of sugar and milk and then chalk powder. Okay. When you add sugar, 1 spoon of sugar to beaker 1, add 1 spoon of sugar to beaker 1, then milk to beaker 2 and chalk powder to beaker 3. Then mix it with the glass rod. Then allow it for, keep it aside for some time. After some time, you will observe that the beaker containing sugar is formed a homogeneous mixture. That is, the solution, you can find a sugar solution which is homogeneous and clear. When you see second beaker, you will see milk solution. So there, like, it looks like homogeneous, but it is not homogeneous. So in third beaker, when you see the third beaker, some chalk particles are like they were suspended in the solution, that is water. So a solution in which like you get a homogeneous mixture, then it is called true solution. And the solution where we added milk, but that solution it's not transparent, but it looks like homogeneous, but it is heterogeneous. So milk solution is colloidal solution, and the solution or the water or the beaker which contain a chalk powder, the chalk powder which is suspended in it is called suspension solution. So we will learn this one by one now. Okay. So now what is meant by true solution or solution? So here solution is formed from solvent and solute and solvent. When solute and solvent are mixed, solution is formed. So here solution is a homogeneous mixture of two or more substances. See here, in solution, solute is present in less quantity and solvent is present in more quantity. So these are the two components which makes the solution. Anybody have doubt in this solution part? Okay, Anjali. Next, we will move to the slide. So when we hear about solution, we think that only liquid solution, like liquid, solid or gas or liquid are dissolved to make a solution. Like, do you know, like there is a, like what about solid and gaseous solution? Is there a solid solution or gaseous solution? Anybody? Okay, John. So there are three types of solution: liquid solution, gaseous solution, and solid solution. Okay. Now, let's take an example. Alloy. Can anybody tell answer, like what is meant by alloy? Alloy is a homogeneous mixture of two or more metals. Two or more metals. Sometimes metals are non-metals. Two or more metals. Sometimes metals and non-metals. So here, if metals, yeah, John. So here, see, both the solvent and solute both are metals here. That is, metals are in solid state. So alloy is a solid solution. Okay. Next, air. Air is a mixture of gas in gas. We know that air is a mixture of different gases, that is nitrogen, oxygen, carbon dioxide, etc. Here, in this air, solvent is also gas and solute is also gas. So, hence, air is a gaseous solution. Next, we will see example of liquid solution. A solution of sugar in water is a solid in liquid solution. That is, solid is solute and liquid is solution. Sorry, liquid is solvent. So, sugar solution is liquid in solid in liquid solution. Next, a solution of iodine in alcohol is known as tincture iodine. Tincture of iodine. So, here iodine is solute and alcohol is solvent. So, here it is also a solid in liquid solution. Next, aerated drinks like soda, water, etc. are gas in liquid solution. Here, gas is solute and liquid is solution. liquid is solvent. So when this is solvent, so it is gas in liquid solution. Now let us move to the next slide. That is properties of solution. As we discussed, so as we discussed, solution is a homogeneous mixture. Sorry. As we discussed, solution is a homogeneous mixture. Means there is a uniformity of composition throughout. That the composition uniformity is throughout, like there is no separation in the solution. That is properties of solution is first one is it is a homogeneous mixture. So next is the particles in homogeneous mixture are very small. That is, they are smaller than 1 nanometer or 10 raised to minus meter. So the particles of solution we cannot see by our naked eyes. Okay. So due to that small size of the particles of the solution, these particles cannot scatter the beam of light passing through the solution, and so the path of light is not visible. So the solute particle cannot be separated from the solution by the process called filtration. So the solute particles do not settle in the solution because they are very small and they are stable. So they do not settle at the bottom and they are stable. Okay, we'll move to the next. Here, concentration of solution. So there are two types, concentrated solution and dilute solution. In laboratory, during experiment and all, we use concentrated solution also, diluted solution also. So what is meant by concentrated solution? Here it is a concentrated solution and it is diluted solution. Dilute solution. In concentrated solution, solute particles are more compared to solvent particles, and in dilute solution, solute particles are very less. So in concentrated solution have large amount of solute in it, but in dilute solution, relatively small amount of solute dissolved in the solution. Got it? Next, we will move to the next topic. That is concentration of solution in that saturated solution and unsaturated solution. So saturated solution means sometimes we feel bored, or sometimes when we read and we don't feel ki now we have to read again, we have to take rest sometime. So then after reading we get saturated, there is no space, we get saturated. So we tell ki I am now saturated, tomorrow I will learn. That kind of thing we will tell. So saturated means that no more solute can be dissolved in that saturated solution. Saturated means already it is filled. So saturated means no more solute can be dissolved at a given temperature. In unsaturated solution, only less solutes are present in unsaturated solution. So in unsaturated solution, more solute can be dissolved. Saturated solution means no more solute can be dissolved, but in unsaturated solution, more solute can be dissolved. Okay, next. So, what is meant by solubility? The amount of solute present in saturated solution at any temperature is called solubility. Okay. Next, we will move to this part. So, concentration of solution can be calculated by using many formulas. These are the main three formulas that are used to calculate the concentration of the solution. So first, if the mass of the solute and mass of the solution is given, then the concentration of the solution can be calculated by using the formula mass by mass percentage is equal to mass of solute divided by mass of solution into 100. Similarly, when volume of the solution and the mass of the solvent is given, then concentration of solution can be calculated by using this formula. Similarly, when volume of the solution and volume of the solute is given, then volume percentage can be calculated by using this formula. Okay. Now let us calculate one. Now let us say one example. Here, a solution contains 40 gram of common salt and 32 gram of water. Here, solute is 40 gram of common salt, NaCl, and solvent is 320 gram of water. Can anyone tell which formula can use to calculate the concentration of solution? Anyone? Can anyone tell? Just see this. Which formula can be used to calculate this problem? Nobody? Okay. By mass by. Yeah. Mass by mass. Yes. Niranjan, John. Yes. Yes. Okay. So here, mass of the solute is given and mass of the solvent is given. Therefore, mass percentage is equal to mass of the solute is 40 gram. Mass of the, sorry, this is solution, okay. $40 gram of solute is given and 320 gram of solution is given. Can anyone tell answer for this? Yes, Anjali. So it is 12.5%. Yeah, 25 to 12.5%. The concentration of the solution percentage of mass percentage of the solution is 12.5%. Next, Yes, yes. It is solvent only, okay? Sorry. We have to calculate the mass percentage of the solution. Mass percentage of the solution is mass of the solute divided by mass of the solvent into 100 gives mass percentage of the solution. Yeah. Yes, yes. We will discuss this, okay? 1 minute. Okay, we will move to the next. I was on mute, sorry. So here, suspension is the second type of solution. Here, suspension is a heterogeneous mixture. So can you see here? It's we have mud in water. So here you can see two distinct parts and sorry, yeah, two distinct parts and the particles of uh, sorry, some issue is there. Okay. So here suspension means it's a heterogeneous mixture. Here you can see two distinct like one distinct boundary is there, but the particles are suspended in the solution. Next is the particles of suspension can be seen by naked eyes. Here the particles of suspension are larger, so we can see the particles of suspension. Okay. Sorry, there is a issue with my network. Sorry. So next is the particles of suspension scatter a beam of light passing through and it makes path visible. So since the particles of suspension are larger, so you can see the particles of suspension, it's here like it is suspended in the solvent. So when beam of light is passed through the suspension, the particle of suspension can scatter the beam of light and make its path visible, path of the light visible. Okay. Next is suspension is unstable. So here suspension gets like the particles of suspension get settled. So suspension is unstable. Okay. So they can be separated from mixture by the process called filtration. Here in this suspension, like when you filter the suspension, so you will get clear water as a filtrate and that mud particle as a residue. So suspension can be filtered. Okay. Next, we will move to the colloid. Here you can see this is a milk. So after seeing this, you can say that it's a homogeneous mixture, but it's not homogeneous mixture, it is a heterogeneous mixture because the particle size of colloid is very small. So individual particles of colloids cannot be seen through a naked eye. So the particles of colloids are uniformly spread throughout the solution. So colloidal solution is a heterogeneous mixture. So next we will see the Tyndall effect in colloidal solution. So we said that the colloidal solution is heterogeneous mixture and the particles of colloidal solutions are very small, but they are not that much small. So that like when beam of light is passed through the colloidal solution, the particles of colloidal solution scatter the beam of light and allow its like you can see visible path of the light. So you can see this Tyndall effect in forest also. When sun rays pass through the like come from in forest, so the in forest mist is present. So this mist contains water vapor. Water vapor acts as a suspension of colloid. When this suspension of colloid, when sun light comes, so this particle acts as a like water vapor acts as a colloidal like suspended particle of colloid. So we can see this light like this rays, sun rays. Okay. Next, we will see the properties of colloid. As we said, colloid is a heterogeneous mixture. The size of the particles of colloid is too small. So individual particles of colloid we cannot see through our naked eyes. So colloids are big enough to scatter a beam of light as we discussed in Tyndall effect, passing through it and make its path visible. So colloidal particles are very small, but they are not that much small. They will not scatter the beam of light. They will scatter the beam of light and make its path visible. They are stable because colloidal particles will not get settled at the bottom. Okay. So as we discussed that colloidal particles are very small, so they cannot be separate. The particles of colloid cannot be separated by filtration. Okay. Now like how we can separate the particles of colloid? Here, the particles of colloids can be separated by centrifugation. So here in this centrifugation, what happens like the suspended particles of colloids can be separated from its liquid by churning at a high speed. So when it is turned at high speed, the particles of colloids get separated. Okay. So these are the types of colloids. When dispersed phase and dispersed medium are like, for example, when dispersed phase is liquid, then dispersing medium is gas, then the type of colloid is known aerosol. So example of this is fog, mist, clouds. Next, when dispersed phase in colloid is solid and dispersing medium is gas, the type of colloid is aerosol. So similarly, so there are different states of matters which are dispersed phase and dispersed medium. So main are like these are the main. For example, so you just remember that dispersed phase is a small quantity. It's like a solute, and dispersed medium is like a solvent. So when it's like, for example, when solid is dispersed phase and liquid is dispersed medium. Type of colloid formed is sol. So you have heard about milk of magnesia. It is used as antacid. So it is a sol. Okay, for example, mud also it is a sol. You can see solid particles in mud. So similarly, this is solid when solid is dispersed phase and solid is dispersing medium, then the type of colloid is not solid sol. Okay, Sriraj, no problem. Okay. So there is I made one mistake in the calculation. We'll go to the calculation, okay? Here, yeah. Okay, it's okay. Lakshmi, yes, it's correct. So here we have 40 gram of NaCl that I'll erase this, okay? Yeah, Lakshmi, it's correct. Sorry, So I made a mistake. Like I thought it is a solution, so it is a solvent. So for solution means, as we know that solution is equal to solute plus solvent. It will always come solute by solvent. No, solute by solution. Okay. So here you can see the formula here. Mass by mass percent is equal to mass of solute divided by mass of solution into 100. Okay. We have solute is given 40 gram and solution is equal to 40 plus 40 gram plus 320 gram. Okay. So the mass of solution is 40 plus 40, 360 gram. Okay. So when we put this value in formula, m by m percentage is equal to 40, that is mass by solute, divided by 360, that is mass by solution, gives 11.1. This is the correct answer. Yeah, Deepak, it's correct only. This is the correct answer. Previous one was wrong. Okay. I misunderstood that 320 gram is a solution. Okay. The correct answer is 11.1. Understood, everyone? Do you have any doubt in this? Anybody? No, right? Okay, we will move to the, yeah. If you have doubt, please, once more, I will explain. Here, the solution contains 40 gram of common salt. Here, common salt is, I will erase, okay? First, I will erase and I will explain. So, here, 40 gram of common salt is given. Common salt means it is a solute. Solute, mass of solute is 40 gram. Okay. And 320 gram of water. Water is solvent. Solvent is 320 gram. As we discussed before, solution is equal to solute plus solvent. Here, both of are in gram like mass. So for that we have to use this formula. That is Mass by mass percentage is equal to mass of solute divided by mass of solution into 100. Understood? So here mass by mass percentage is equal to mass by mass of solute divided by mass of solution. But in question, there is like they have not given mass of solution. So we know that solution is equal to like solution is made up of solute and solvent. So they have given quantity of solute and solution. Sorry, solute and solvent. Now we have to add those. Solution means solute plus solvent. Solute is 40 gram. Solvent is 320 gram. Since mass of solution is 360 gram. Now we have to substitute these values in this formula. Mass by mass percentage is equal to mass of solute is 40 gram. Then mass of solution is 360 gram. Then result will be 11.1%. Oh, sound is not coming. Now I am audible to you. Hello? Can you hear me? Okay. Okay. Thank you. Okay. Christine, have you understood? Christine? Yeah, okay. So this is the correct method, okay? Okay. So before, okay. Let's move to the another part, that is like question part. So here we have already discussed about true solution, suspension and colloid. So can you answer this? Out of which like in these true solution, colloids and suspension, which of do not show Tyndall effect? Which of the following do not show Tyndall effect? Can anyone tell? Yes, Anjali, true solution, yes. Next, Sriraj, yes, good. Yeah. So here in true solution, there is like the particle size is too small, but okay, the particle is size is too small. So when light is passed through the true solution, the particles of true solution do not scatter the light and path of light is not visible. Hence, true solution will not show Tyndall effect. Okay. Next, arrange true solution, colloids and suspension in the decreasing order of their stability. Can anyone tell answer for this? Stability means the part in which the particles will not like if the particle is settled in any solution, then it is like it is called as unstable. If the particles are not settled, then it is called stable. So can anyone tell decreasing order of stability of between stability of true solution, colloids and suspension? Okay. So see here. So in solution, particles are not settled. Okay, like here this point you can see suspension colloid true solution. Yeah, good, Anjali. So you can see here that the solute particles cannot separate it from the mixture by the process of filtration. The solute particles do not settle down when left undisturbed. So that is solution is stable. So if the particles get settled, then that solution we call it as unstable. Here the particles are not settled, when we left undisturbed. So true solution is stable. Similarly, in colloid, suspension here. So in suspension, particles get settled. So in suspension, like it is unstable. The particles are unstable. But in colloid, the particles we will not be able to see the particles with our naked eyes. But compared to suspension, here the particle will not get settled. See here, in properties of colloids, you can see here suspension colloid true. Yes, good. So here they do not settle down when left undisturbed. In colloid also, the particles will not get settled when undisturbed. That is, colloid is quite stable. So now you can tell. So you can give answer for this. Like already many people have answered for this. Good. Okay. Good all. So here decreasing order of stability is suspension is sorry. Yeah. Suspension is unstable. True solution is highly stable and colloid is also stable. So the decreasing order of stability is this. Next, arrange the true solution, colloid and suspension in the increasing order of their particle size. Can anyone tell answer for this? Yeah. Particle size, increasing order of, yes. Increasing order, Niranjan. Increasing order, okay. Sriraj, good. True solution, colloid, suspension. Yes. Yes, Anjali. Yes, Niranjan. Okay. So, as we already discussed, that the particle size of true solution is very small, so it will not scatter the light. And similarly, when compared to suspension, particle size of colloid is very small. Whereas we have seen that milk is a colloid, so we cannot see individual particles of milk. So with the naked eyes, so colloid also like has particles. The size of particle of colloid is small compared to suspension. So the increasing order of particle size is true solution, colloid and suspension. Ma'am, I am Niranjana. Sorry, Niranjana. Sorry, okay. Niranjana. Okay. Next, we will move to the physical change and chemical change. So, in physical change, we have already observed that like when we tear a paper, does the new product is formed when we tear a paper? Anyone? When we tear a paper, does new product is formed? No, Sriraj. Okay. So here when we tear paper, the paper sizes get reduced. So that size, density, shape, melting point, boiling point, we'll call it as physical properties. So Deepak, for what you said is size of the paper get reduced. Yes. So here physical change, in physical change, only physical properties such as density, shape, size get changed, but no new substance is formed. For example, you have seen yesterday we have studied the interconversion of states of matter. So water exists in three states, that is solid state, liquid state, and gaseous state. Solid state, the solid state of water is ice. The liquid state of water is water only, and the gaseous state of water is steam or vapor. So when ice is heated, it gets converted into water. When water is heated, it gets converted into steam. When steam is cooled, it gets converted into water. Then when water is cooled or freeze, it gets converted into ice. So interconversion of state of matter is also physical change, because the chemical composition of water remains same, but the state gets changes. So in physical change, no new substances are formed. Only state of the state or physical properties of the physical property gets changed. So when we break a piece of wood into smaller pieces, can we get a new wood or new any product, or a piece of wood only we will get? So wood is also like, when we break a piece of wood into smaller pieces, the size of the wood is get reduced, but no new product is formed. So the change in which no new product is formed, but the physical properties of a substance is changed, then that change is known as physical change. Okay, only smaller size of wood. Yes. Yes, Sriraj. Okay. Let's move to the chemical change. So I think, can anyone give example of chemical change? Any example? So in chemical change, one substance reacts with another substance. Cooking of food, yes, it's chemical change. Burning of paper, yes. Cooking, yes. So in chemical change, one substance reacts with another substance and they undergo change in chemical composition. For example, when carbon reacts with oxygen, carbon dioxide is formed. Okay. Similarly, when magnesium reacts with oxygen, magnesium oxide is formed. So here one substance reacts with another substance to form a new substance which have different chemical composition. Burning of magnesium, burning of incense stick, yes. Burning is a chemical change. Here, chemical change brings change in chemical properties of matter and the substances. Okay. Next, we will now give answer for this. Classify the following as chemical or physical change. Anyone? First, melting of butter in pan is physical change or chemical change? Anyone? Yeah. Melting of butter in pan is a physical change. Next, yes. Then cutting of grass is also a physical change. Only the size of grass is reduced in cutting of grass, and almaria gets rusted is a chemical change, because rust is formed when, yes, Sriraj, rust is formed when iron or iron substance come in contact with air and forms iron oxide. So it is a chemical change. Next is water boils to form a steam is a physical change. As we already discussed, the change of state of matter is a physical change. Next, dissolving salt in water is also physical change. Next, move to the other slide. Yes. Types of pure substances. There are two types of pure substances, elements and compounds. So elements cannot be broken down into simpler substances by chemical reactions. So there are elements are classified into metals, non-metals and metalloids. So now we will see some examples of elements, and we will see the properties of also. Here gold, mercury, copper, aluminum are the metals. So here metals are lustrous, they are ductile, they are good conductor of electricity, and they are malleable, and they are sonorous. So these are the properties of metals. They are lustrous, sonorous, malleable, ductile, good conductor of heat and electricity. So some examples of non-metals are hydrogen, oxygen. So hydrogen and oxygen are carbon. These all are the examples of, even diamond is also an example of non-metal. So it is the hardest non-metals. It is an exception for non-metal. Even in metals, mercury is a liquid, is a only a metal which is liquid in state. So in non-metal, bromine is a liquid in state. Diamond is made up of carbon particles. Yes, it's an allotrope of carbon. I'll take few more minutes to complete the class. Okay. So non-metals are in like they are in gaseous state. They are brittle. They are non-sonorous, non-ductile, non-ductile, non-sonorous, non-malleable, bad conductor of electricity. But non-metals are in gaseous state. But here non-metals are, we cannot say like non-metals are brittles. As you see, carbon, it is brittle, but one of the most, like diamond is a non-metal, but it is the hardest substance known. So metalloid. Next comes metalloid. Metalloid has the properties between both metals and non-metals. So some examples of metalloids are silicon, boron, germanium, antimony, etc. Okay, let's move to the other point, that is compounds. So as we already discussed, sodium chloride, that is salt, is a compound. So compound composed of two or more elements. That is, for example, Na plus Cl. Na is also element and Cl also element. So compound composed of two or more elements chemically combined with one another in a fixed proportion. For example, water. The chemical formula of water is H2O. So all the except like all the pure water contains these elements, that is hydrogen and oxygen. They are combined in a fixed ratio, that is 1:8. So compound composed of two or more elements that are chemically combined with one another in a fixed ratio. So the ratio of water will be 1:8 in every water. Okay, in every pure water. Next, properties of compound. Elements are combined in a fixed proportion by mass. Yeah, as I already discussed, in water, that is water, that is the composition of, like, the elements are already fixed, combined in a fixed proportion, that is 1:8. Next, properties of compounds are entirely different from its constituent elements. So for example, carbon and oxygen when combined to form carbon dioxide. Okay, this equation is not balanced, but just for your information, I am telling. Carbon is combustible. Oxygen is supporter of combustion. Carbon is combustible. Oxygen is supporter of combustion. Carbon is combustible. Oxygen is supporter of combustion. Carbon is supporter of combustion. Carbon is combustible. Oxygen is supporter of combustion. Carbon is supporter of combustion. Oxygen is supporter of combustion. combustion, and carbon dioxide is used as fire extinguisher. It extinguishes fire extinguishes. So here the constituent elements like carbon and oxygen, when combined with each other, they form carbon dioxide. But the properties of carbon dioxide is different from the properties of each elements of like carbon and oxygen. So here, this is the next property of compound. Next, compound cannot be separated by physical method. As compounds are formed by the chemical reaction, they cannot be separated. The components like constituent elements of compound cannot be separated by physical methods. So it's a homogeneous substance. Yeah, compound is a homogeneous substance. Okay, next we will move to the difference between the compounds and mixtures. These are the some differences between the compounds and mixtures. Next, classify the following into compounds and elements, compound and mixture. Fast, like, give answer for this. No? Marble is compound or mixture or element? Fast, quick. Okay. No one. Okay then. So I will only tell. Marble is a compound. Marble is a calcium carbonate. It is a compound. Okay. Air is a mixture. Yes. Diamond is made of which one is element? No, marble is not element. Marble is compound. It is made up of calcium carbonate. Calcium, carbon, and oxygen. As we discussed, compound is made up of two or more elements. Calcium is element, carbon is element, oxygen is element. So air is a mixture. Yes, air is a mixture. Gold is element. So gold is a element. It cannot be broken down into simple substance by any chemical methods. Next, brass is a mixture. As I said, brass is a alloy. So brass is a mixture of metals, and milk is also mixture. As we discussed that colloidal solution, that milk is a mixture. Okay. Next. So today we have discussed that matter are classified into pure substances and mixtures. So pure substances are classified into elements and compounds. Mixtures are classified into homogeneous and heterogeneous mixtures. Okay. Yesterday we discussed there was some doubt regarding the sublimation. So sublimation is conversion of substance from solid to the gaseous state without becoming liquid. So this is known as sublimation. Solid to gas is sublimation, and gas to solid is deposition. Solid is deposition. So yesterday we were discussing on this, right, Sriraj? Okay. Next, some examples of sublimations are. Yeah. So that process we call it as sublimation only. So conversion of solid carbon dioxide into gaseous carbon dioxide is also process by the process of sublimation only, and conversion of like camphor get converted into its gaseous state. It is also sublimation process. So conversion of solid to gaseous state is a sublimation process. So anybody have doubt regarding today's class and yesterday's class? You can discuss now. You can raise the hand. I will ask I will unmute you guys. No doubts? Okay, Sriraj. It's clear, ma'am. Anybody have doubts? Please ask me. I will explain. If you have not understood anything, please tell me. I will explain you again. Okay, Anjali. Okay. Then we will end up this call. Okay. Thank you, everyone. Thank you. Have a nice day. Okay, Sriraj. Okay, Sriraj. Lakshmi, thank you. Okay. Bye. Have a nice day. Christine, Deepak. Okay, bye. Bye, John. Bye, Noel. Okay. Okay, Anjali, bye. Okay, then. Let's wind up the call. Okay.